Good morning, all. We have started with the lecture series on earth pressure. Initially, we have started with the retaining wall and its types. After that, we have started with the earth pressure theories, in which we have seen active earth pressure and passive earth pressure, their coefficients. In the third session, we have seen Rankine's earth pressure theories, where in our Rankine's earth pressure theory, we have seen K0, Kp, that is nothing but the active earth pressure coefficient and passive earth pressure coefficient. And after that, we have solved the problem based on the same concept. This is the things that we have covered. Now, for today's session, we will going to cover the next part, that is further submerge different condition for a Rankine's theory. We'll start with the first fundamental assumptions and the formula which will be required while solving the numericals. Next stage is backfill is submerged only to parts of its height. So, in which we're going to see how that formula is being created. The backfill above the water table is considered to be moist. The lateral pressure above the water table is due to the most unit weight of the soil, and below the water table is the sum of that due to the submerged unit weight of the soil and the water pressure. So, formula will be Ka gamma H2 plus Ka gam dash H1 plus gamma W H1. Lateral pressure at the base of the wall will be Kpy H2 plus Kp gamma dash H1 plus gamma W H1. So in a first diagram, you will be able to see this one partially submerged backfill where total height is given as H, H2 and H1 they have given, moist sand gamma unit weight is given, saturated sand effective unit weight gamma dash is given. So lateral pressure for a partially submerged backfill will be Ka gamma H2 plus Ka gamma dash H1 plus gamma W H1 for the active condition, and for the passive condition partially submerged backfill with different friction angles above and below the water table is given as Ka gamma H2 plus Ka gamma dash H1 gamma W H1. So these are the things. After that, next we are going to see the submerged condition is effect of uniform surcharge. So basically, the extra loading carried by the retaining structure is known as the surcharge. Nothing how it is calculated is nothing but the surcharge is equals to gamma into height. Unit weight into height. It's a calculation part. So in the case of wall retaining in a backfill with a horizontal surface level with the top of the wall and carrying a uniform surcharge of intensity Q per unit area, so vertical stress at every elevation in a backfill is considered to be increased by Q. So sigma H equals to A gamma H plus KAQ in active condition, and sigma H equals to KP gamma Z plus KPQ passive case condition. So in a case of uniform surcharge, the condition for a wall with the uniform surcharge is cohesionless backfill with a unit weight gamma is given, Z datum is given, Q uniform surcharge which is coming on that backfill on the retaining wall it is given. So lateral pressure diagram will be in this way only, Ka gamma Z in an inclined condition plus KQ. So the total pressure will be Ka gamma H plus KQ in a pass and for the active condition, and for a passive condition, alternative manner of showing the interval is KQ plus gamma H. So K gamma can come on a bracket side, H plus He. So these are the uh, formulas which will be required while solving the numerical based on the same concept for the effect of uniform surcharge. Next part. Now effect of incline surcharge on a backfill, we're going to see. Rankine theory for this case is based on the assumption that a conjugate relationship exists between the vertical pressure and the lateral pressure on a vertical planes within the soil adjacent to a retaining wall. So we're going to see the formula. So in case of Ka condition and Kp condition, Ka active earth pressure coefficient, Kp passive earth pressure coefficient. So we'll go to see the formula. Ka is equals to cos beta in bracket cos beta minus square root cos square beta minus cos square phi divided by cos beta plus square root cos square beta minus cos square phi. Phi is the angle of intersection, beta is the angle is given to the incline to the retaining wall. Kp coefficient of passive earth pressure condition cos of beta in bracket cos of beta plus square root of cos square beta minus cos square phi divided by cos beta minus cos square beta minus cos square phi. So this is what conjugate stresses on element which is given. A element which is nothing but the dimension perpendicular to the plane of a figure is also unity, which is all the forces which is carrying on a single element is given. Next, the condition is of active pressure distribution has been shown. So next part we're going to see calculation for the active earth pressure of a cohesive soil. Sigma 1 equals to sigma 3 n phi plus 2c root of n phi, where in a case of active condition, sigma 1 equals to yz, sigma 3 equals to sigma h. Then next part is formula gamma z equals to sigma h n phi plus 2c square root of n phi. Sigma h equals to gamma z upon n phi minus 2c upon root of n phi. So 1 by n phi equals to Ka for cohesionless soil. Sigma 3c equals to sigma h Ka gamma z minus 2c upon root of n phi. So this is for condition for active air pressure condition where surface z equals to 0 and sigma h equals to minus 2c upon root of n phi. So this is what the diagram which is shown as the cohesive field is given with a height of h. So the pressure which is coming on K gamma h plus gamma h by nq. So negative values of the active earth pressure to a depth of equal to half of the so-called critical depth. So the total active thrust per unit length of the wall is obtained by Pa equals to 1 by 2 gamma h square divided by n phi minus 2c upon root of n phi into h. So for a pure clay, we can easily calculate the phi when angle of intersection is 0, where P equals to 1 by 2 gamma h square minus 2ch plus 2c square by gamma, where c is a critical depth. So net pressure over the depth of 2zc is 0. So the formula will be Pa equals to 1 by 2 gamma h square cot square alpha minus 2ch cot of alpha, where alpha is the angle of intersection. After that, h is height, gamma is unit weight. So PA is nothing but the formula which will be required for an active case condition. Now in the same way, on a same basis, passive earth pressure of a cohesive soil, the formula will be sigma 1 equals to sigma 3 n phi plus 2c square root of n phi, where for passive case sigma 3 equals to yz and sigma 1 equals to sigma hc. So Kp and equals to n phi in the usual notation it is given. So sigma 1c equals to sigma hc plus gamma z n phi plus 2c root of n phi. So total passive resistance per unit length of the wall is Pp. It is nothing but the passive pressure condition, which is equals to 1 by 2 gamma h square n phi plus 2ch root of n phi. So this is what the diagram which is shown for the passive earth condition. H is the your height is given. After that 2c root of n phi h by 2 2c root of n phi gamma h n phi. So formula for the passive condition is equals to 1 by 2 gamma h square tan square alpha plus 2ch tan of alpha, where alpha is the angle of shear resistance, h is the height, gamma is the unit weight, c is the cohesion that is to be provided in the numerical. So these are the formula that we're going to use for solving the numerical based on passive earth condition. Next, now let us see a single formula for the same concept. We will going to solve the problem. A vertical excavation was made in a clay deposit having a weight of 20 kilonewton per meter cube. Unit weight is given as 20 kilonewton per meter cube. It caved in after the depth of digging reached to 4 meters. So taking the angle of intersection to be 0, calculate the value of cohesion. Now this is what the first part of the numerical. Initially we have to calculate the cohesion. They have not given the value of the C value. So by considering the angle of intersection 0, we have to start with the first fundamental. The critical height HC of an unsupported vertical cut in a cohesive soil is given by HC critical height equals to 4c upon gamma tan of alpha. Now, as angle of intersection is 0, tan of alpha equals to tan of 45 plus 5 by 2, where your phi is 0. So, tan 45 is nothing but the sin 45 upon cos 45, which is equals to 1. So, C equals to HC gamma upon 4. So 420 upon 4 equals to 20 kilonewton per meter square. So this is what the value of the cohesion that we have calculated. After that, in a numerical, they said if the same clay is used as a backfill against a retaining wall up to height of 8 meters, calculate the total active earth pressure. So total active earth pressure is given by the equation PA equals to 1 by 2 into gamma is 20, H is 8 square, cot square alpha is 1, minus 2 into C into H cot of alpha. So 2 into 20 into 8 into cot of alpha is 1. So we'll get the answer as PA equals to 320 kilonewton per meter square. So this is nothing but the total active earth pressure in the same condition. Now we'll proceed with the next point, total passive air pressure. Equation by using PP is equals to 1 by 2 gamma H tan square alpha plus 2CH tan of alpha. So now we're going to put the values 1 by 2 gamma into 20 is given as unit weight, 20 into height is given as 8, so it's 8 square tan of alpha plus 2 into 20 into 8. So 2CH value you have put it. So at the end we'll get the answer as 960 kilonewton per meter. So this is nothing but the total passive earth pressure in this condition. So this is what the numerical, where we solve the numerical based on active pressure condition, total passive earth pressure condition for a different submerged backfill condition. So this is all about this calculation part. We will stop here. Thank you.